All right, so this is a tricky SAT problem I wanted to go over with you that a lot of students are going to mess up on, but it's really not that difficult when we understand some keywords here. So we have two frequency graphs. It says two data sets of 23 integers, each are summarized in the histogram shown. For each of the histograms, the first interval represents the frequency of integers greater than or equal to 10, but less than 20. The second interval represents the frequency of integers greater than or equal to 20, but less than 30, and so on. What is the smallest possible difference between the mean of dataset A and the mean of dataset B? Okay, so first keywords here is smallest possible difference between the mean. All right, so how could we get the smallest possible difference? Well, if you notice in the wording of the problem, we are including the low end of the bins. So we're including the low end, but not including the high end. So for example, in data set A, uh, 29 would be the high end of this first bin here. Okay? So what we want to do is if we're going to find the mean using the difference, smallest possible difference, what we want is we want to take data set A and we first want to get what this mean would be if we started at the low end. Okay, so the lowest end we could be at is 20, 30, 40, and 50. All right, so if we calculate the mean here, it would be 20 times 3 plus, and then it would be 30 times 4 plus 40 times 7 plus, and then it would be 50 times 9. And if we do that correctly, we're going to get 910. And if we divide that by 23, that would give us around 39.5 as the mean. All right. So what that is doing is it's calculating. So for example, it tells us that there's three data points between 20, including 20, up to 29. So 30 goes to the next bin. So it's unlikely, but the smallest possible scenario would be all three of the data points have the value of 20. Same thing for the next bin. All four of them are 30. So that would be the lowest mean I can get out of data set A. All right. So we want to do the same concept now with data set B. So with data set B, we want to focus on the highest mean we can get out of data set B. So that would give us the smallest possible difference between means. Now, if we look at the wording in the problem here, we include 10, but we don't include 20. So 20 moves to the next bin. So the highest value we can get out of data set B would be 19 times 3 plus 29 times 4 plus 39 times 7 plus 49 times 9, which is going to equal, if we do that correctly, the calculation would be 887 divided by 23, which is around 38.5 when we divide by 23. So the correct answer here would be the mean difference would be around 1. Okay? Now, we don't have to go through this whole calculation. We can do this just with one data set and see that the difference between the values is going to be 1. These are all going to stay the same. So we can just do this with one bin and we would get that same calculation where the answer would be 1 here to save us some work and some time. Okay? I know a lot of students on this problem would get the low end of both graphs. So for example, they would have um, 10, here they would have 10, 20, 30, and 40, and then they would get a difference of 10, and they would get the wrong answer here as the mean of 10. So again, the keywords here is we're looking at smallest possible difference. So what you have to do is you have to go to the edges of the histogram. Okay, so the lowest you can get on one compared to the highest average mean you can get on the other. All right? I hope this video was helpful. I hope if you see this on the SAT, you get this correct. Thanks for watching. Please like and subscribe for more videos like this.